For almost 50 years, we've been sending probes to the edge of our solar system. And now, they've found something nobody expected. A wall made of fire at 90,000 degrees. But here's the thing. It's not actually a wall. And we just discovered it might be protecting something we never even knew was there. A spiral. Fossils from the dawn of time. Objects that shouldn't exist where they are. NASA's discoveries at the edge of our solar system are rewriting everything we thought we knew about where we live in space. And the more we look, the stranger it gets. So let's talk about boundaries. The edge of the solar system isn't where you think it is. Not at Pluto. Not even close. The actual boundary sits billions of miles farther out. It's called the heliosphere, a vast invisible bubble blown by the sun itself. The sun constantly fires a stream of charged particles outward, the solar wind. It rushes past every planet, past Pluto, past everything we normally think of as the solar system. That wind forms a shield that protects our solar system from harsh interstellar radiation. Gas, dust, the matter between stars, where the sun's influence finally ends, where solar wind meets interstellar pressure, you reach the heliopause. That's the real edge. And for decades, we had no idea what it looked like, or what was happening there. Then Voyager 1 crossed it in 2012. Voyager 2 followed in 2018. And what they found changed everything. You're traveling through space at 38,000 miles per hour. You've been flying for over 35 years. You're farther from Earth than anything humans have ever built. Then, something strange happens. Voyager 1 crosses an invisible boundary, the heliopause, the edge of the sun's influence, where the solar wind collides with interstellar space. Suddenly, the energy of the plasma around it spikes. Imagine an insane temperature, 50,000 to 90,000 degrees Fahrenheit. Scientists call this boundary the Wall of Fire. But here's the part that sounds impossible. Voyager doesn't melt. It doesn't burn. It doesn't even get warm. Because in deep space, temperature doesn't mean heat. The plasma may register as tens of thousands of degrees, but it's so thin, so empty, that almost no energy is transferred. It's like standing in a room where the air molecules are moving at bullet speeds, but there are only 3 of them. What creates this heat? Collision, friction, the solar wind slamming into interstellar wind, particles crashing into each other at impossible speeds, energy building up at the boundary like waves hitting a breakwater. And both Voyagers measured something else unexpected: the magnetic field. Inside the heliosphere, it points one way. Outside, scientists thought it would flip direction completely. It didn't. The magnetic field beyond the heliopause runs parallel to the one inside, almost like they're connected. Like the sun's influence reaches farther than we thought, threading invisible lines of force into interstellar space. We're still trying to figure out what that means. But the Wall of Fire isn't the only surprise waiting at the edge. In February 2025, NASA scientists ran simulations on the Pleiades supercomputer, one of the most powerful machines on Earth. They were trying to map something we've never actually seen: the Oort cloud. Have you heard of the Oort cloud? That theoretical shell of icy objects way, way out there, somewhere between 2,000 and 100,000 times farther from the Sun than Earth is. It's where comets come from, the frozen leftovers from when our solar system formed 4.6 billion years ago. We've always assumed it was just a scattered mess, a spherical shell of random ice chunks drifting in the dark. The simulation revealed something else. We did not find chaos. The inner Oort cloud, the region between 1,000 and 10,000 times Earth's distance from the Sun, has structure. Spiral arms, 2 of them, stretching 15,000 astronomical units end to end, arranged like a miniature galaxy tilted against the plane of our solar system. Why? Galactic tide. Out there, the Sun's gravity gets weak enough that other forces take over. The combined gravitational pull of every star, every black hole, every mass concentration in the Milky Way starts to matter. It tugs on those icy objects, slowly organizing them over billions of years into these spiraling patterns. Gravitational forces creating long-term changes in orbits, sculpting them into preferred directions. It's like finding out your backyard has been secretly organized by the entire neighborhood for 4 billion years. And we had no idea. Then there's the fossils. In July 2025, astronomers using Japan's Subaru telescope announced the discovery of something they'd been hunting for years. A new sednoid, only the 4th ever found. Sednoids are weird. They're trans-Neptunian objects, meaning they orbit beyond Neptune, but with orbits so extreme, so elongated and distant that Neptune's gravity can't touch them. Picture this. They swing out hundreds of times farther than Earth, taking thousands of years to complete one lap around the Sun. They nicknamed this one Ammonite, after the fossil, because its orbit has been stable for 4.5 billion years, unchanged since the solar system was young. Ammonite comes as close as 66 astronomical units to the Sun, twice Neptune's distance, and swings out to 252 astronomical units. It's somewhere between 140 and 240 miles wide. It's been out there, circling, since before life existed on Earth. But here's what makes it really interesting. Its orbit points the wrong way. The other 3 known sednoids all have orbits that cluster in the same direction, like they're being herded by something massive. Some scientists think that something is Planet 9, a hypothetical giant planet lurking in the outer solar system that we haven't found yet. Ammonite's orbit doesn't fit the pattern. It's anti-aligned, pointing the opposite direction, which means either Planet 9 doesn't exist, or it used to exist and got kicked out of the solar system billions of years ago, leaving these strange orbits as evidence of something that happened when our cosmic neighborhood was still taking shape. Something extraordinary. So what does all this mean? The edge of our solar system is way more complex, way more dramatic and alive than we imagined. There's a wall of fire we have to cross to reach interstellar space. There's a spiral structure organizing the frozen debris from our system's formation. There are ancient objects with orbits that tell stories about events billions of years ago that we're only now starting to read. And we're just beginning to look. Voyager 1 is still out there, over 15 billion miles away, sending back data on a signal that takes more than 23 hours to reach Earth. It won't reach the Oort cloud for another 300 years. Then, it'll take 300,000 more to pass through it. New telescopes, like the Vera Rubin Observatory, are about to start scanning the sky for more of these distant objects. Every discovery changes the map. Every weird orbit asks new questions. Where did sednoids come from? What really shapes the Oort cloud? Is there a Planet 9? Or was there one that got ejected? What other structures are hiding out there in the dark? The edge of our solar system isn't an edge at all. It's a door, and it's full of secrets. If you're curious about what else we're discovering out there in the deep dark of space, mysteries we're solving and questions we didn't even know to ask, hit subscribe. Because we're just getting started. And trust me, the universe has a lot more surprises waiting for us at the edge.